All right, we're going to work on number 4. Thank goodness we did number 3 in class. We're going to do some diagrams to show this airplane's movement. Airplane flies 185 kilometers per hour at an angle of 65 degrees north of east. Okay, so first line that you will draw would be east, north of east. Okay, and what is north of this line? This direction. Okay. So the resultant would be this line right here. Okay. And it says that that resultant is 185 kilometers per hour. It's a terrible hour, but that's what it is. And the angle, 65 degrees. Okay, so let's just break that one into its x and y components right away. You got an x component to that velocity, you have a y component to that velocity. X is equal to 185 times the cosine of 65. It's cosine because it's adjacent to it. Multiply by 185 because that's the hypotenuse. 185 cosine 65 gets you 78.2. And I'm going to label the direction as east. Not the answer, but part of the answer. Next part, I'll do Vy. I'll do the y's in red. All right. Once you start to notice the pattern here, that there's a pattern here, when you have cosine for the first one, next one, it's going to be sine. Same numbers, just with sine. So the y component of that velocity, 185 sine of 65 is 167.7. That's kilometers per hour, and it is towards the north. All right, next part. It's blown. We edited this one the way it was stated a little bit to say that it was blown 65 degrees west of south by an 85 kilometer per hour wind. West of south. South is the last one, so we start with it. And we are blown not east, but west of that. And so the resultant is this. Okay. So the dashed line is the direction the wind is actually blowing. These two lines represent two directions that we can call and make up that one direction. And that's 85 kilometers per hour. And the angle comes from right here. It is the angle that's made by the first line and the resultant. Okay. Southwest. So that's this angle here that we turned. And it is also 65 degrees. Okay, so let's find the x and y components. Here's your y component, up and down. Here's your x component. Oops, that's supposed to be blue. Here's your x component. Let's do the x component first. That's the opposite side, so this one's going to be sine. It is 85 sine of 65. So the x portion of that velocity, 85 sine of 65, is 77 kilometers per hour. But this one is not east, it is west. Okay. So we had some eastward velocity. If there was no wind, we would have quite a bit of eastward velocity. But so much of this wind is blowing in the westward direction in our face that these are almost going to cancel each other out. We'll look at that in just a moment. All right, and so for the y, we have 85 cosine of 65. The y component, 85 cosine 65, is 35.9 kilometers per hour. And that one is towards the south. All right, again, same thing in the y direction, that we have a lot of velocity in the y direction, 167.7 kilometers per hour, but we're flying into this wind that's slowing us down. So we're going to now add these together to get some total velocity in the x direction, total velocity in the y direction. And how do I add these? Well, east and north are the positive directions, right? So west and south must be the negative direction. So I need to subtract between these numbers. So do 78.2 minus 77, and that will give me 1.2 kilometers per hour towards the east. Okay? I called east the positive number, so when you do the subtraction and you get a positive number, that means it's in the positive direction, which is east. Same thing here, 167 minus 35.9, and you should get 131.8. We had more northward velocity than south, so this is north. So those are our two components of the velocity. But we're not done yet. We need to use those components to create, so we split them up so that we could add them. Now that we've added them, we will put them back together and find the result. So what we're finding is if we have some total velocity that was created by the flight of our plane and the motion of the wind, the speed of the wind. And we want to look at the output of that. An arrow here, we know that we have 131. Wow, that's a large arrow. Was not prepared for that. 131.8 kilometers per hour towards the north. And we also have 1.2. Of course, it's tiny. 1.2 kilometers per hour towards the east. And the resultant is this red line, and that's what we're searching for. Okay, that is the payoff. That's the valuable information here, is to know if the wind's blowing like this, where are we going in the plane? Imagine if there was some wind on your flight and they didn't know how it was going to affect the plane. They just were hoping for the best. Let's hope that that's not what they're doing. Okay, so we want to find this velocity or speed, and we want to find the direction so that it is a velocity. We want to know how fast and in what direction. All right, for the how fast portion, you're going to use Pythagorean theorem. A squared plus b squared equals c squared. 131.8 squared plus 1.2 squared equals c squared. Well, this is actually the velocity. All right, let me do that calculation. (17,372.68) equals velocity squared, not the velocity squared. I just take the square root of that thing. Square root at 131.8. We've got three significant digits on these things, so I'm going to say 132 kilometers per hour. All right, and that's a speed. Okay, 132 kilometers per hour. Great, that's how fast you're going. But in which direction? To do that, we'll use tangent inverse again to find theta. Tangent inverse of opposite over adjacent. I get theta equals 0.52 degrees. So 0.52 degrees. I usually put a leading zero here. 0.52 degrees. And what direction? Okay, so not straight north. There's a little bit of east there. So we are going a little bit east of north. And that's number 4. All right, next video will be 5.